Hello and welcome back to the Additive Snack podcast. I'm your host, Fabian Alefeld, and today I'm super excited because we do have a very special guest with us, Dr. Nadine Lippa from Wilson. We're here to discuss a fascinating project she's been working on, which is now one of the most, if not the most, seen AM application in the world, and that is the Airless Prototype Basketball. Nadine, welcome to Additive Snack.
Thanks, Fabian. Appreciate that. Happy to be here.
So let me start by taking you back to February 18th of 2023, which I think was one of the most unforgettable days in your career, where you were on site at the NBA dunk contest. And I can already imagine the sounds of fans cheering, the adrenaline you had when you walked in. Can you tell us a bit more about that experience? How did it feel to be at the NBA dunk contest? And also, how did you get there?
It felt very surreal. Definitely wasn't expecting to get there this year, if at all. And so I think even just being on site, you could feel the electricity of the event, and everyone anticipates the dunk contest every year. So knowing that we were going to play a special part in that was also just really exhilarating. Another big part was just coming into the arena. I had a ticket to get in, but there was a little bit of maneuvering among the team to get me down onto the floor. But my teammates stepped up and they sorted that out along with some of our NBA colleagues, and they got me courtside for the dunk contest.
That's awesome. And I'm sure you were super nervous as well. And then the face you saw was, if I remember correctly, Shaquille O'Neal. Is that right?
Yes. So basically the ball was inside this huge case that we had designed. Myself, my colleague Hudson Vantrease, Alan Libowitz, and a few other people had designed this huge case that had a fog machine inside.
Mm-hmm.
And so the reason, like the actual rationale why I needed to be courtside was not just to meet Shaq, but was also to press the fog machine button. So as soon as I got down there, Hudson handed me the button and they got ready to roll it out, but I couldn't see the case. And so I kept holding up this fob, for lack of a better word, and making my way through the crowd of this wall of very tall basketball players.
Yeah.
And as I approached the front, I saw the back of Shaq's head.
Wow.
And realized that I was standing right next to him in order to get a perfect view of my duty to run the fog machine.
Did that deter you from pressing the button?
No, I think in a nervous way, I was just hitting that button. And it was funny because as people saw me holding it up, the players were like, "Oh, she's doing something important. Let her up front." So it was my key to the kingdom to get to the front of the line, which was nice.
That's awesome. The magic key. And then what happened at the dunk contest?
Yeah. So I get to the front of the line and he has his Shaq cam that he brings with him everywhere. And I didn't know he had an assistant. So he keeps leaning over and I'm standing between Shaq and his assistant. So he mistook me for his assistant.
Oh.
And he keeps turning around and looking at me and saying, "Where's my girl? Where's my girl?" And I'm like, "I'm not your girl." So like, I'm someone else's girl, which was very funny, but he was very nice. And we exchanged just a few words and he saw what I was doing and commented that the ball was pretty cool. So that was a unexpected but pleasant surprise. And you're right. I was super nervous watching KJ Martin get ready and excited for him to be in the dunk contest. And then, of course, the ball's debut. Was it going to perform? And was the whole system going to run the way we were hoping it to?
Oh, that's incredible. You know, who can say that they conversed with Shaq? And it's, I'm sure, a moment that you'll never forget. And it's also really cool that Additive really got you there. So what happened? What happened next?
Yeah, so then what happened next is the ball was wheeled out, the fog machine functioned as expected, the team was all ready, and KJ was about to do his dunk. And actually, we thought that it was going to be used for the first dunk, but it ended up a last minute change. He used it for his second dunk. So that was a little bit of the team was what's going to happen. And there is some excitement and fluidity of sport that it's not like a theater performance where you know what's going to happen next if you're backstage. It's like the players are responding to real-time events. So that was all the emotions at that moment because you're like, are we going to use it?
Yeah.
But then he actually did, and he did a really awesome dunk where it worked together with his dad, Kenyon Martin, who had also played in the NBA. And the dad threw it off the backboard. KJ jumped up, dropped the ball down to his ankles, and dunked it in. And he made it, and the ball bounced, and he dribbled it, and the judges had checked it out. So we were golden.
Yeah, that's when years of work all come into one little moment. So I want to step back a little bit because I think the basketball story is so unique, and it almost sounds so normal that there is a 3D printed basketball on a court. But that's a long journey for yourself and for an organization like Wilson to get to that point. Can you tell me a little bit about the journey of Wilson into additive and some of the applications that you've worked on prior to this moment?
Sure. Yeah. Wilson has been working with on additive prior to me starting in 2018. So I'm not a full historian of all of our efforts prior to then, but a lot of our industry used 3D printing, especially for prototyping.
Hmm.
We've had a couple different machines in our innovation center facility for those purposes or outsourced for various projects. And then when I started in 2018 was right at the time when our industry and maybe others were starting to consider additive more for producing the good instead of just prototyping the good. So when I came in, that was when the idea was first floated. What are all the different ways we can make a basketball
Hmm.
besides how we make a basketball today? And basketball really just being any of our balls, but starting with a major part of our business, a round ball, that kind of thing. So additive was one of, at the time, 6 technologies that I started investigating
Hmm.
for reinventing basketball and talked to a lot of different companies. I really knew fairly little about additive, especially relative to what I've known through this project.
Hmm.
So just understanding the entire ecosystem that's involved. At first, when you enter, you think that you're going to talk to one company and they'll be your one-stop shop, but that's certainly not the case in any manufacturing environment. So seeing that in additive was also pretty interesting.
Yeah, for sure. And yeah, you're totally right. Additive is neither a one-stop shop nor a plug and play technology. So there's a lot that has to come together in order to build that, yeah, real full value and supply chain. And before touching that basketball, which we'll also show in a second, you guys also worked on some applications. I remember a driver versus driver contest and some other applications as well. Which ones came prior to the basketball?
Yep. So the 2 that we've released publicly, yeah, Wilson worked with EOS on a driver versus driver. So driver versus driver, back up. That's a reality show that Wilson Golf was running, I think with the Golf Channel.
Mhm.
And us was used as a technology for people to make a fully functional driver head for the show. So it's like a reality show competition where different people design clubs to optimize different performance parameters. So that was one project. And then maybe others in this space have heard about the project Wilson and myself worked on with a 3D printed pickleball paddle.
It's, I think, interesting and important to mention that the basketball doesn't just come up out of nowhere. There were various steps that you and Wilson took and gathered, I'm sure, also a lot of experience in building these value chains to get where you are today. Do you have the basketball with you? Can we show it?
I do.
Nice. All right.
Here it is.
Can you explain to especially the listeners on Apple Podcasts and Spotify what you're holding up right now?
Sure. So the ball that I'm holding up right now is the ball that KJ Martin used in the dunk contest. And it's a black lattice. It's looks like a basketball. It has the channels of a basketball. It has a Wilson logo and an NBA logo at the pole of the ball. And the lattice itself is hexagonal, also have maybe some pentagons in there. And as I mentioned, 2 layers with radial beams projecting into the second layer.
That's awesome. It is one of the coolest polymer applications we've certainly seen in the industry. Now, let's dive deeper into that basketball because, as I mentioned, it is super complex to develop these types of applications, especially if we look at the true performance. I think anybody can print a basketball today, but printing a basketball that can perform as a conventional basketball, that's the crux. So, how did you guys get there? How did you select a technology, design iterations? What were the process steps you went along with?
Sure. So as I mentioned in 2018, I started just learning about the ecosystem and had no idea where to start. Certainly looked at a lot of different technologies. I don't think powder was necessarily obvious to me from the beginning, but knowing the print bed size of SLS made it much easier to navigate just from the beginning because we weren't having to make these little tiny samples and try
Mhm.
to understand one day when the print volume is bigger, how will those perform? So that was a big deal for navigating that. And then from the material side, I think the material that we use wasn't even necessarily available when I started in 2018.
Mm.
An interesting lesson for me as an innovator and a future looking person is sometimes when you start a project, you hope that you're getting out the on ramp as that material or that solution is also entering the picture so that you can be a fast mover. Definitely the first prototypes we were making were like PA12 and were just very conceptual. I would show them to people and they would be like, "What is this? Is
Mhm.
this just something I put on my shelf?" And to explain to people that with a lattice, we could make something that would be soft and would rebound and wouldn't hurt your fingers, wouldn't feel like you're catching a cheese grater. And people could not conceptualize that. But I think the people in innovation, we understood that was coming down the pipe and we were just waiting for the right solution.
That's awesome. And yeah, can you talk a little bit about the iterative process that you guys went through? I'm sure there were a lot of tests and you had to tweak certain parameters and designs of the ball.
Sure. So we know that a basketball is 600 grams approximately.
Hmm.
So I think every time we went through an iteration, we started with, we want to get, end goal is getting to 600 grams. If I hand a player something that's 650, that's all they're going to tell me. They're not going to tell me anything else.
Really?
And same thing if I hand them something that's 550. So we knew that was very critical to hit that mass.
Hmm.
So whether we were printing in PA12 or in our existing material, that was a primary concern. And then I would say we started with the design of try to make it look basketball like. So creating channels, making this structure low-B, that actually didn't come overnight. That really was able to be implemented once we had General Lattice join us. Before that, actually, some of these features were really difficult to implement in some of the other CAD programs that we were using. So that also was a work in progress. So I would say, in terms of the iterative process, we were as technology came to us on the software side, we were able to improve the design. And as technology came to us on the printing side or on the material side, that affected the design as well, meeting the mass requirements, trying to get the rebound that we wanted, adding different features, changing cell sizes. So we definitely started off with something that was basketball like.
Hmm.
And now we have something that is a basketball.
Yeah, that's a perfect definition, actually. Basketball like to a true basketball. And I'm sure that there were a lot of challenges along the way that came unexpected that you guys had to figure out. What were some of the biggest challenges you came across?
Definitely a lot of challenges. One of the challenges was actually translating some of the material requirements to the various people in this ecosystem.
Mhm.
So I had an idea of what those material requirements needed to be, and then sometimes would speak with people that had different ideas about what that should be. I guess an example I can give early on is one of the people I was speaking with very early on, I explained I needed a ball that rebounds back to your hand. I needed something with very good energy return. And I drew a little plot of what that looked like from a material standpoint. And I was like, this is what I want. And they went off and they worked to try to find a material combination that would work for us. And they came back and they said, of all the materials I reviewed, I think metal would be your best solution. It's like, oh,
What?
maybe this isn't going to work out. I
That's funny.
understand why it came out that way because metal does function in its elastic region. And at the time, we didn't have the elastomers available to us that we do now. So I don't think it was unreasonable that they came to that conclusion, but it was more that's just an example of a challenge where you have something in mind that you want. And if when someone's answering the question with what's available, it just didn't, it wasn't even feasible for our application.
That's super funny. And you're right. Yeah, we actually have, I think when I first started EOS, I remember seeing a small round metal ball in the office back then in 2016 or so. And that thing really bounced back all the way into your hand. So I could,
Yes, I would be terrified to catch it.
yeah, yeah. Or not. And it hits your head. That's hilarious.
Right.
Challenges aside though, this thing is the real deal. And as you said in the beginning, this basketball was at the NBA dunk contest. And there's been a lot of buzz around the Airless Prototype so far. Can you tell me a little bit about the interest that it has seen from the market?
Sure. So there's probably two ways that you can talk about this. One is the digital response, and one is the in-person response. So from a digital standpoint, we had a making of video that my colleague Jen Breyer led from our creative team. The video was really great. And actually, the video was so good that it got picked up by a lot of different sources online, sometimes chopped and screwed a little bit, and some details added that may or may not be exactly precise, but nonetheless, those videos and our video all took off. One video in particular, or a series of videos, went viral
Hmm.
and were even picked up by Sports Center. So that was really unexpected. I think for me, I kept envisioning the pinnacle was the dunk contest itself. But what I didn't expect was this second wave of interest from this huge digital community of people, just everything from criticizing the ball or to celebrating the ball, wanting to know more, wanting to know when they could buy one. Just an entire conversation opened up online that has been very interesting to engage in.
Yeah, I can totally relate. One of my friends here in Austin reached out to me because he saw that video. And he said, Fabi, I never would have thought that I see anything related to you on ESPN. Because I'm German. I don't watch football. I don't watch basketball or baseball yet. And he always makes fun of me for that. He says he's going to have to teach my son how to throw a ball. So that was a pretty interesting story for me as well, to see a project that we were engaged with, to see on such a large channel. And you even won some awards. Can you talk about those?
Yes, I absolutely can. I actually had a second part of my question I also would like to
All right, then let's jump
cover
into that one.
too. Yeah, sure. So I talked a little bit about people's response on the digital side, but we've also had, for the very first time after 5 years of keeping everything secret,
Mm-hmm.
we've been able to get this ball out to the masses to some degree. The ball was shown at NBA Crossover, which is like a fan event that happens alongside the dunk contest and the whole All-Star weekend. And that was like all basketball fans, which was interesting. The ball went to two different trade show, or yeah, I guess three different trade shows in Additive. So it went to AMUG,
Mm-hmm.
Rapid, and Rapid 3D Tech. And then also, so that's a different audience, right? That's all additive nerds like us.
Yeah.
And then the ball most recently went to the Wall Street Journal Future of Everything conference, which is a different cross section, more like future tech designer, not necessarily athletes, but looking future manufacturing kind of groups. Among those three different groups of people, we've been getting a lot of feedback that has been very helpful for me, not having been able to gain these insights prior.
Yeah, and I'm sure also stressful, because all of a sudden everybody, including myself, wants to talk to Nadine about her really cool project. Let's look a little bit ahead. This is, as I mentioned earlier, one of the, not if not the most seen additive manufacturing application. Prior to that, may have been an aerospace product, and now we've actually have a consumer product that has been seen by many folks out there, including engineers. And I do wonder what the future of additive manufacturing looks like for Wilson. Now, do you have that true success story that kind of proves that people are receptive for this type of manufacturing technology?
Sure. I would say from a marketing standpoint, we do have a success story.
Mm-hmm.
And from a marketing of additive and awareness and that kind of thing, we have a success story. But my ultimate goal is not just to show a cool project that we're working on. My ultimate goal is to make a product.
Sure.
And so from my perspective, showing this ball publicly has just kicked off a passionate effort to try to commercialize this in some way, shape, or form. So definitely interested to do that and learning more about the business side of this effort. learning also about how we're using a completely different supply chain, completely different methods, and even a little more R&D to do, excuse me, a little more R&D to get the scale up and running. It's very interesting to me in my career, but just to explain to people, and I think sometimes people see something on a screen or on TV and they think, okay, cool, they're going to release these next week. There is still quite a lot of work to be done by a huge team of people to bring this to life.
Yeah, totally. And if I would compare it with the software world, maybe you've shown the MVP, and the MVP may have shown that you're onto something, and now you've proven to yourself that it's worth the investment to go into the next stage. Is that a correct comparison?
Yeah, I think so. Absolutely. And it's also just very cool to see that we've started a trend. Even since the dunk contest, we've seen other people creating various types of balls. And again, not the engineering that goes into making a fully functional basketball or other sporting good product, but to see that we've ignited this trend and this excitement around additive in sport is just really great as well.
Yeah, 100%. Ever since you guys released this product or this prototype, I've seen folks on LinkedIn, for example, even designing their own balls and sharing their designs. Yeah, I think, as you said, everybody in theory can print a ball, but printing it to spec, that is the true challenge. And that's the true engineering behind additive in that space. Nadine, I want to ask you one more question, and that is, you are not only a great engineer and a PhD that works for Wilson, you're also a mom, you have a family. And if I understand correctly, you even involved your family, or your family was involved in this project in various facets. Can we talk about that? Because I think it's such a cool story.
Yeah, absolutely. What's really special is I have 3 little kids. I have twin girls that are 4.5, and I have a son who's 2.5. And when I say I've been working on this project for 5 years, that was before I had any children. So it's been very fun. My kids have seen me bring home various prototypes across all my projects. And to them, it's just another ball. It's been very interesting as an engineer to just bring home some very ugly sample that we were going to throw away. And the kids are gravitating toward it. And then all they want to do is play with that ball. And so learning through their eyes what the next generation may be interested in has been very interesting. And then specific to this 3D printing project, I originally couldn't bring home any samples because my husband works in the additive manufacturing area.
Yeah.
And so knowing that he was doing that was something I had to basically keep completely quiet about at home until we started working with EOS, and my husband, Dave, also started working at EOS. So that was fun because he was on the engineering side and for EOS, and I was on the engineering side for Wilson. And so samples came home, the kids got to play with them. My daughter, Ariana, was the first person to ever dunk a 3D printed basketball. And my son, Revo, was the first man to ever, a boy, to ever dunk a basketball, and Tasman as well. It's been pretty cool just to go from something that was completely separate from my family to being able to integrate that.
Yeah, it's an awesome story. You got unbiased testers at home that will probably tell you if something is not a good idea or doesn't work. But you're raising future engineers there, hopefully at least, which I think is very incredible. I even got to meet your kids and your family a few weeks ago. Yeah, what can I say? Really fun family. Got to read the Bad Seed book to them. That was a really fun night. Nadine,
Yes.
I want to thank you so much for being on this podcast and sharing your experience, your expertise, and also your stories with us. I think a lot of people get inspired by the product that you've released. Not only existing engineers, but hopefully also the next generation. Thanks again, and it was a pleasure to have you on the show.
Thank you so much. This has been great.